Hello, welcome to my online class with the computer-aided measurement and control with Reddy Gyosu. In this topic, in this fourth week, we will discuss about LED. And in this case, I will skip discussion with LCD and 7-segment LED. Because in Arduino kits, we don't have this kind of parts. So we just focus in LED. In this class, our objective is learning how to operate with digital output in Arduino Uno and learning how to deal with the LED. In this case, I will skip with the presentation with LCD and 7-segment LED. The device requirement in this lecture is one Arduino Uno, this one, and maybe you need 5 LED and resistor 220 ohm. And this LCD and 7-segment LED are not available in Arduino starter kit, so these experiments are skipped. This one LCD and this one 7-segment LED. If you want to learn this, you can still read the code in this lecture and you can study by yourself. And we discuss about digital output. What is actually digital output? Digital output is output signal with only two states, either high, 5 volts, or low, or 0 volts. Similar, something like this. You can see this one is kind of digital output. Low and high, low and high, and low with specified time. In this one, time when the signal is high, and this one, the low time when the voltage output is low. In Arduino, digital pin, actually all digital pins is available in Arduino Uno. This one and all pin, actually digital pin. Microcontroller, basically they are calculate or execute voltage, digital voltage. So all pins, you can use it for digital input or output. And this one is breadboard. In this experiment, we will use this breadboard when we want to place a circuit, and this one is connection in the breadboard. You place a connection electrical component in the center with connection something like this. It is pin, maybe vertical line, connect like this. And this one is gap. You cannot create a separate line. And this one is when you place for power line. In this power line is all pin is connected. Pin up are connected. And as you can see in here, I have a Arduino starter kit in this my table, and you can open it. Something like hang. This one is breadboard, and you can open. This one is breadboard used in this experiment. This pin is connected, and this one is for power supply, positive and negative. Okay, that one is breadboard. And this one, breadboard again, place for your vertical component in the center with the vertical line. It's this five dots. These are connected each other. And this one is, for example, you place for power supply 5 volts or ground, something like this. In Arduino, available a power supply 3.3 volts and 5 volts, and also 3 grounds, in this ground and this ground. And we move a discussion with LED. LED is actually light emitting diode. It is a semiconductor light source where if there is electron flow, fills the holes and releasing energy in form of photon or light. This one is LED schematic diagram. If there is a electric flow from here, electron flow, and the electron will move or jump to the holes. During the jump, it will produce emission light in terms of photon or light. This kind of example of LED, as you can see, in this case red LED, and this one is segment LED. The type of phosphor type can maybe red or green or yellow. And advantage of this LED is operate in low voltage and fast response speed and long life, of course low cost, maybe about back one. And application, of course, in LED lamp, maybe in car or digital clock, advertising board, and display elements, etc. And this one is a diagram of LED. It consists of, this one is epoxy, and maybe there is a wire bond and reflective cavity, semiconductor die. I'm not expert in this, but actually this LED, there is gap in here where is the electron will jump to from cathode to anode. The cathode, you can see there is a flat spot in here, and it's the circle, and you can see distinguish from flat spot in here. This is the cathode, and the long one, if you can see from the LED has a leg. You can see the long one is positive and short one is cathode. Or if you have LED with same leg, you can distinguish from this flat spot. This flat spot is actually for negative side. You can see the shape is like this, and this flat is for negative and positive. This one is LED when it's on, something like this. And this operation for LED, usually it requires in the low voltage 1 to 4 voltage or 3.5 voltage with this limited current 10 milliampere or 550 milliampere. The connection should be connect in series with the resistor to limit the current. In this case, don't connect directly LED to the light source. You need a resistor to limit the current around this milliampere, 10 milliampere to 50 milliampere. Always connect with resistor, otherwise your LED will be broken. In electric circuit, the LED symbol by like this, by triangular, and this vertical line, and there is a cross arrow here, something like this. This one symbol for LED in the circuit. This one is LED connect in series with resistor. This one is anode, cathode, short leg For anode is long length, something like this. This one is example when you want to operate LED using 5 volts power and limited current 20 milliampere. So the example equation is simple with 5 volts minus 2 volts divided R. So the current flow in here 20 milliampere. So the voltage around the LED 3 volts. So you need the resistor about 150 ohm for maximum current 20 milliampere. So if we want to use LED, the resistor should be no less than 150 ohm. 220 ohm is, I think, is better for this LED. And this one, the resistor to limit the current in electrical symbol, something like this, with the I don't know, it's just line like this, and this one rectangular, depends on standard. And this one, how to know the value of resistor? There is they distinguish by the color band, something like this, first band, 2 band, 3 band, and this one tolerance. In this case, for 5 bands, you can see this one is different number of color. For black, 0. This one chocolate, brown is 1, and red 2, orange 3, something like this. This one is similar for between 1 and 2 and 3 color. And for fourth line is a multiplication value. This one, for example, for resistor, they have 5 bands. So the color 1 is red. So it's a 2, and this is also red, this is 2, and this is 0, 0. And the last one is for multiplication 1. So the value is 220 ohm. With tolerance is this gold. Minus 5% value. In case of second case, this color is the second color. This color, godong-sek color, chocolate color is the 1, and this one 0, black, second color, third color is also 0, and this one also this godong-sek color. So, multiply 10. So this equal 1000 ohm or 1 kilo ohm. Something like this. For third case, the same. This one is godong-sek color, and then chomgom-sek color, third and second and third, and multiplication of red. So this one is about 10 kilo ohm. Something like this. This color is similar with gold, but I think this is not gold. I'm so confused. So that one is resistor to limit the current is how you know how to know the value of resistor based on the color sign on the resistor. And you can download application from Android, maybe available Android app for resistor color modes, and you can check the value, and you just put in maybe the color first line and second line, third line, fourth line, and you can know the value of the resistor color. That is the easy way. And let's begin the experiment 1. LED experiment 1 is just only LED on and off. And this one is LED, and this blue one is Arduino. Connect in the pin port 13, and you connect the positive part of LED with the resistor 220, and this one ground, just connect to the ground of Arduino Uno. This one connection diagram, something like this. Connect with the 13 pin, and you need only one LED. Maybe red LED is requirement. And operating with within 20 volt with 20 milliampere, and this one diameter 5 millimeter. And you can use the resistor 220. And the objective in this experiment, first, only digital output understanding and only flashing control practice, understanding using pinMode function, understanding using digitalWrite, and the materials is Arduino Uno, LED resistor, and breadboard. And this one is code. First, I have in here breadboard, and LED, anyway, and resistor, resistor 22 ohm. First to do is connect this LED. Oh, this one is not focused. Okay, as you can see, the long arm is cathode, long arm is anode, and the short one is cathode. Remember, just connect something like this. Okay, and this one positive side, connect like this, and you need cable and Arduino. I have Arduino here. If you want to attach with this board, you can attach with this tab here. You can open it and stick on it in here, but in this case I don't do that. And this one Arduino Uno, and USB cable. Connect this one in here. Just connect the positive side with pin 13. Connect with pin 13. Pin 13 and negative. This part series with the LED port and ground. This ground. And let's check I have LED program already, and check the code. First, the code. In this case, we define delay time by constant define function. Define delay time 1000 and int variable pin LED we set 13 because we use pin 13. And in void setup function, in this bracket you write inside pinMode and type pin LED, comma output, and we set output for pin 13. And in void loop, we simply just write digitalWrite and then set the pin high first. What is pin LED? Pin LEDs we already declare is 13 first. In here, and delay, in this case we divide it 2. So this one is 500 because we define first 1000 divided 2. And LED off with same delay 500. And this one description of the code you can read. And this one is video, for example, how to play. Or LED blinking after you upload the code. In this case, I have the sketch similar with the in this presentation. Define 13 and pinMode set as output, and just simply write digitalWrite. Remember this one W big one, and also this big capital M. If you write something like this, it doesn't work. Remember, in C code is very case sensitive, so you should declare with this pinMode something like this. So remember, should be same. digitalWrite, delay, and digitalWrite, and set the flow and delay again. So in this case, let's see. Let's see our LED. If we already set up in here, check the COM Arduino Uno and click upload. See, in this case, LED will blinking as 500 millisecond. That is the first experiment in this class. Simply just blinking the LED with time 500 millisecond. I hope you understand this code. First, I repeat again. With define the time delay 1000 and put the pin for LED. So we declare the variable pin LED int equal 13. As replace pin LED equal 13 in this for code. You can also declare like a 13, but in this case we already declare as pin LED, so it's similar. So this one pin mode, we declare the digital output for pin 13. And in void loop, the Arduino will execute this code again and again in loop function. So we just comment the LED off and on. So is LED high, delay divided 2, and time delay off divided 2, same. Okay, that one is LED on and off. For another case, in case A, flash the LED every 0.2 seconds and changing delay time 200 milliseconds. So you just change the delay time for 100 seconds. In this case, I have a code already. We change the delay. How about the effect of change a delay? This one is delay for 500 milliseconds. So if we change this 400, so it means we will more faster blinking about 200 milliseconds. Just simply upload this code. I already typed this, so the blinking of the LED more faster. As you can see the video, LED blinking more faster. The video is there is a lagging. Very interesting. This is the blinking more faster LED. For how about changing to 100? So you can see the LED more faster blinking. In this case, you can see blinking more faster. That is the delay, effect of delay. Delay is function of waiting program. So basically, you just changing the on and off with equal time. This one is 200. I'm sorry, this divided 100. 400, 200, you're right, 200. Sorry, it's 100 millisecond. On and off 200 millisecond. That is digital output. And the case B, repeat process. When this case of on 0.8 and off 0.2. First, you need to define time for delay on is 100 and off is 200. So basically you just want to more on. So this one is 200 millisecond and this one is 800 millisecond. I have this code already defined. First delay on 800 and time delay off 200, and all the rest code you just change the delay time on in here and time delay off. So the LED will on 800 millisecond and will off 200 millisecond. Let's upload the code. This is our previous code already, and change the upload the code. So this one is with on 800 millisecond and off 200 millisecond. That is for case B. So next, this one is case code for case A. I already explained. Just change it the value of previously 1000 become 400. In case B, you just need define define new function, new constant time delay on, and new constant time delay of 200 and 800, and change the delay in here and delay off in here. That was LCD, very basic, on and off. So we begin experiment 2. In this experiment 2, we will use the 5 LEDs and connect to in the pin 2, 3, 4, 5, and 6. We need 5 pins, and we require 5 LED, maybe yellow, red, green, yellow, and red again, and all resistor using 220 ohm. Or if you have 330 ohm, you can use it. And this one schematic diagram, something like this. Connect with positive. First LED, 220 resistor, and LED with the cathode negative and anode positive. And this one connect to pin 3, connect to pin 4, connect pin 5, pin 6. And this one in place in breadboard using pin 2, pin 3, pin 4, pin 5, pin 6. And place a resistor like this, and in this case we use ground in this line is all ground, and you just connect the ground, put in here, and it become connected each other, something like this. And in my desk still ready red, let's do it. Just plug out the power, and you just need more LED in here. Yellow, green, red, yellow again. So we will place the same like in the picture. The short one is negative, you can see. It's not focused. Short one is negative. So just place this one. Yellow, red, and green. Yellow, red, green, yellow. This one ground, connect in here. Okay. We need our cable. Just place all resistors. Usually for ground is cable, I use black, but in this case I have limited black cable, so I use a color cable. So it doesn't matter. Skills. Sorry, it's nice. So I think the setup is ready. I don't know, you can see clear the LED or not. And ground. Ground. So in this experiment, we just do LED, 5 LED for on first on LED 1, on LED 2, LED 3, LED 4, LED 5, something like this, moving like this. So go back the code. First code is we assign the pin 2, 3, 4, 5. This one, pointer pen. 1, 2, 3, 4, 5, 6. Arduino, and we set delay time 10, and it's void setup. You just put in this all output. We define already 2, 3, 4, 5, 6, LED 1, LED 2, LED 3, LED 4, and 5. And first, you using digitalWrite for LED 1 high, on, and this one set delay time, and it's off for LED 1 and LED 2 high, and then off again on LED 3, on LED 4, on LED 5, something like this. So we have this one, Arduino setup. Where it goes. And I already have the code in here. Just simply upload the Arduino. COM3 and upload this. Compiling sketch, it will upload to Arduino. And you can see the LED will blinking sequentially from LED 1, 2, 3, 4, 5. Something like this. I think it's experiment very easy for you. You can follow, and from this code, sorry, from this code, first output for from pin 2, 3, 4, 5, 6 output, and simply just high and set delay and low. Delay, set pin 2 high and delay low, and then pin LED 3, 4, 5, something like this. It will go like this. Okay, that's what this second experiment of LED. This one is video already I show you. If you change it, the delay more faster. Maybe. Oh, wait, check a minute. The delay 100 in my program is 100. If you change the delay more, 50, it will more faster. Something like this. I hope you can follow me. Okay. How about change it 20? You can see the LED more faster blinking. Something like this. There is LED blinking. And we can also do different approach programming. Similar output, but in this case, we simplify the program by using for function, and this one also for function. By arrange the pin in array, assignment pin 2, 3, 4, 5, 6, and this delay is same using for, because basically you just put all output for all pin 2, 3, 4, 5, 6 pin for all outputs, and you just sequence this program again and again, and you can define using for. And you can also use the different approach programming for output using byte. In this case, you can use byte by define for binary, something like this. Using definition of DDRD for output, this one for in case for 0, this one for input, and in case for 1, you set for pin register for output. And in void loop, using simply just port D, and you assign number of byte, and you set byte 0. What is this number? Actually, this port of D. So basically, you use pin 2, 3, 4, 5, 6 in Arduino. In this case, you use only port D, and 0, 0 mean port, pin 0 and pin 1 in Arduino Uno. So you declare the binary output something like this. And in experiment 3, you just simply rearrange the LED arrangement from first is LED 2 on first, and LED 4 second on, LED 1 third on, and LED 3 fourth on, and LED 5 will on in last. Something like this. This one is code for changing arrangement of LED. Simply you just changing the byte number in here. First is LED second on, and then this on, and then this LED 2 on, and LED, I think this one is LED 4 on, and LED 5 on. If you want to don't use the byte, something like this, you can use say pinMode by changing arrangement of pins, something like this. Changing LED 2 in here, and then LED 4 on first, LED 1 on, and 3 on, and 5 on. I have the code. This one is for traffic light. I don't have it. That one. Maybe this one. I don't open it. Okay, good. This one. Upload this. So the sequence of LED will be changing. Something like this. If you still don't understand what is this, I will explain again. This one is the bit number for you point the output and input in port using binary number. This one is DDRD because you put in the LED on the port D. So set the register in Arduino for input and output. 0 for input and 1 is output. This one is port Arduino. One, 2, 3, 4, 5, 6, 7, 8. This one is pin 0. This one pin 7. This one is LSB. This one MSB. In this case, you put the register DDRD by using this one. It means you put the 0. Sorry, this one start from LSB. So this one 0, 0, 1, 1, 1, 1, and 1. This one you put the register for input and output. This one for input, this one for output, because you put use pin 3, pin 2 until pin 6. And you set the register using port D function. Port D function. Port D equal, just simply put the bit number. On or off. In this case, you want to first LED 3 on first. So LED 3, this one on, another is 0. So this one, 3 is this one, and this one is 1, this one, and the rest of value 4 is this one. This one is you program using byte number. This is very useful if you're working in not only single port, but you working in for multiple port. You simply just put a digital pin for setting the register or the microcontroller using function of DDRD for set input and output, and using port D you set for high or low function. Similar like digital write. In this case, you use port D. Okay. Okay, now we move the traffic light experiment for LED. In this wiring diagram, we use the pin 2, 3, and 4. And of course, in traffic light, we use you have a text first, red on, and then second one is green on and yellow, last one on, with different delay time. In this experiment, I think it's very easy using traffic light. This one, the pin diagram, thing like this. Let's do this experiment by setting the Arduino in here. Let's take off the power. Yes, I'll take off the LED. Just changing the move this one back green. Sorry, I forgot. Red, yellow, and green. Red, yellow, green. Okay. So we have LED for traffic lights. This one using byte function. I told you this one is for register setting. For pin 2, pin 3, pin 4, you set output. So you set 1. So gong gong, il, gong gong gong. So you just write B capital in here for binary function. And for looping, you just simply set the high using port T, high 1, and then delay. Set delay for red and green and yellow, 1 second, 3 second, 4 second. And this one for green on, LED set in here, binary number, and this one set port yellow. Port yellow is port 3 on, and then delay. This one using function binary. Another function using basic digital write and digital output. You just simply pinMode using like this, output red, green, yellow, and for it loop also digital write. Just simply like high, this is low, low for green, and then put delay and red, low, yellow, low, green, high, and then green delay, and then activate yellow light for traffic light, red off and yellow high, and green low, and delay for yellow. So this one is our last experiment, or this one our previous program, so you have to change it. This program, or you can use this program using port definition and DDRD for register input and output definition. In this case, I will upload this program. Both program are actually same. So in this case, upload this one. Okay, now red will on for 4 seconds. And then green on, and then yellow on. Okay, now touch traffic light. Using this function also same. Come on. This function also same. Using port definition. I already upload. This one, traffic light with red delay 4 seconds, and green delay 3 seconds, and yellow LED delay for 1 second. I define the red LED in pin 2 and yellow LED pin 3 and green LED of pin 4. And then using pin mode, this one 2 and yellow equal 3 and green equals 4. Set output and using digital write, red is high and another yellow and green is low, using red delay and then red low, yellow and green high, delay green and then yellow high, red and green is low, so delay using LED yellow. If you have any question, you can send me email or in this lecture. I hope you understand the LED and using digital write and pin mode, and also using register definition for port D, and this one port D also for setting high or low the pin. Both functions are actually same, but if you use the digital write, this one set for only one by one the pin, high or low. Okay, the test LED. Our lecture is actually finished, and this one is example video. LED red, green, and yellow is same. And this one experiment LCD, I skip this experiment. The skip because we don't have it the LCD in the Arduino kit. We don't have it. You can do by yourself if you have LCD and buy it by yourself, and you can see the install the program in here. Very interesting if you use LCD for measurement and also control the LCD. This one how to display hello world, something like this. And this one moving the word left and to right, something like this. Previously display hello world by blinking the LCD. This one just display LCD. Oh, it's oops. This one already picture, sorry, not video. And also S7 segment LED, also I skip this one. We don't have this function, but if you want to learn, there are two type of LED segment. In this case, using common anode, not common anode, not common cathode. This was using anode. So this one is schematic for common anode. You can learn from this and setting on or low for LED. And this one how you display number by setting the register A, B, C, D, E, F, G. This one, if you use the digitalWrite and pinMode for LED 7 segment, very long this digitalWrite, and yeah, this is how you're writing. This one you display number, and this one using the digit number, and you set how pinMode and digitalWrite were simplify the program using for function. This one, this experiment we skip, okay, and receive character from PC also skip. And in this week you have individual homework. There is will you have to do, in this case you have 2 traffic lights. Your task is how to operate traffic lights together and display 2 serial monitor status of traffic light. It may be the red on or green on or yellow on. You display 2 serial monitor. And this report should be submitted for next week after you watch this lecture. Understand? So the text is this one. Write the traffic light first on and green traffic light 2 on. So this car will move because this is green. So traffic light 2 green, this is red. This car should be stopped, and this one car move. And then display yellow and green on to warn the car to little bit slower moving, and then stop, and then this display green and this one red. So this car will be moved, go through here, and so on. This way delay time or stop. And this one is arrangement for wiring diagram traffic light 1. For example, you have this part and this part traffic light 2. Example for LED. And you use pin 2, 3, 4, 5, 6, 7. So total you use 6 ports for traffic lights. Okay, this is your homework, and this one individual homework, not team homework. So you have to send the report for next week. I hope you enjoy the lecture, and if you have any question, don't hesitate to contact me. And this one, end of lecture. If you have, I will submit this announcement maybe after you watch this video. Okay, thank you very much for your attention.